Students, today we are discussing the last session of this chapter and the fourth type of chemical reaction, that is displacement reaction. For studying what is displacement reaction, we have to conduct an experiment given in activity 4.8. The experiment requires chemicals like copper sulfate, zinc sulfate, iron sulfate, and metals like zinc, iron, and copper. As per the instructions given in activity 4.8, we have to take copper sulfate in beaker A, beaker B also copper sulfate, beaker C zinc sulfate, beaker D iron sulfate, and beaker E zinc sulfate. To beaker A, we want to add the metal zinc, beaker B iron nail, beaker C and D we want to add copper turnings, means copper powder. Beaker E we want to add iron nail, which is a metal.
Displacement reaction. A substitution or displacement reaction is a chemical change in which atoms of one element replace the atoms of another element from the molecules of a compound. Let us take up an example. When an iron knife is dipped in an aqueous solution of copper sulfate, a layer of reddish-brown precipitate is formed on the iron knife. The iron from the knife, being more reactive than copper, displaces it from the copper sulfate solution. The copper so separated gets collected on the surface of iron knife. Activity: take 500 milliliters beakers and add 20 milliliter water in them. Label the beakers as 1, 2, 3, 4 and 5. Add 5 grams copper sulfate to beakers 1 and 2. 5 grams zinc sulfate to 3 and 5. And 5 gram iron sulfate to beaker 4. Now add some iron nails to beakers 2 and 5, copper turnings to beakers 3 and 4, and zinc granules to beaker 1. Then keep the beakers undisturbed for some time and observe carefully. You will observe that the color of the copper sulfate solution changes in beakers 1 and 2. On the other hand, no change is observed in beakers 3, 4 and 5. In beaker 1, zinc Zn replaces copper Cu from the copper sulfate CuSO4 solution to form zinc sulfate ZnSO4 and copper. Because of this, the blue color of copper sulfate disappears and a reddish-brown substance, that is copper, gets deposited at the bottom of the beaker. Similarly, in beaker 2, iron replaces copper from the copper sulfate solution. Hence, the color of the solution changes from blue to green and a reddish-brown substance gets deposited on the iron nail. We conclude that displacement reaction takes place between the more reactive metals to the less reactive metals of salt solution.
So from the experiment, it is clear for you that displacement reaction means the more reactive metal displaces the least reactive metal. In this equation given, suppose A, B and C are metals, and just observe this, what happened after the reaction. A displaces B from its position. So it is clear that A is more reactive than B. So during the reaction, A displaced B from its position and we got a new substance AC plus B. B is displaced because B is less reactive than A. According to activity 4.8, we have taken copper sulfate and zinc metal in beaker A. So what happened during the reaction? Zinc is more reactive than copper. So zinc displaced copper and we got zinc sulfate and copper. Similarly, in beaker B, we have taken copper sulfate and iron nail. So what happened during the reaction? Iron, being more reactive than copper, displaced copper from the solution and took its position. So we got iron sulfate plus copper. So displacement reaction means the more reactive metal displaces the least reactive metal. The last topic of this chapter is uses of metals and non-metals. First we can see what are the common uses of metals. Metals are used for making jewelry, especially gold and silver. Copper is used for making electrical wires and cooking utensils. Aluminium is also used for making electrical cables, packaging, cooking utensils, etc. Metals like iron and steel are widely used in building and home constructions. Mercury, which is a liquid metal, is used in clinical thermometers. In car batteries, lead is used. Coins are made up of nickel. Sodium, which is a very soft metal, is used in table salt. Some nonmetals and their uses are listed below. You know that oxygen is a gas used for breathing, which is a nonmetal. Chlorine is used for purifying water. Phosphorus is used in crackers. Nonmetals like nitrogen is used in fertilizers. Graphite is a good conductor of electricity. Potassium is used in fertilizers. Nitrogen is used by plants. Graphite, which is a nonmetal, is used in making lead. Carbon is used as a fuel. Bromine is used in dyes and pesticides.